Good morning, everybody. How are you today? Last lesson we began with physical changes, and we said, what is a physical change? We said a physical change is a change that new matter will not be formed, so it doesn't give a new substance. Any change of matter that doesn't give new substance, we call it physical change. And the second one is chemical change, this next week inshallah. So physical change is a change that doesn't give a new substance. Then we learned about some examples about physical changes, like ice melting is a physical change. Freezing water, for example. Evaporation, the change of state from liquid into gas. Or condensation is a physical change, or the change from gas into liquid. So all of them we call it what? The change of state. So the change of state is a physical change. Why? Because it doesn't give new substance, it keeps the substance. Ice means solid, and melting means liquid. Water means the same substance. This is water and this is water. Okay, so it didn't change the substance, only it changed the state of matter. Okay, another example, like cutting wood, breaking glass, cutting anything else. Okay, folding water, cutting waters. All of these things are physical changes. Today we are gonna continue with two things: mixtures and solutions. Mixtures and solutions. Okay, what is a mixture and what is a solution? We use this every day. In our daily life, we use mixtures and solutions. Okay, if you wanna eat, for example, you have to put many things together, or one thing or two things. For example, you wanna drink milk, okay, and you wanna put a salad, for example, salad inside it. For example, it includes cucumber, tomatoes, etc. Okay, so mixing substances together give mixtures. What is a mixture? Is a combination. So what is a mixture? Is the combination between two or more substances Okay, so when we put more than one substance with another substance, we call it mixture. So fruit salad is a mixture. Putting sand with water is a mixture. Your pencil case is a mixture because it includes more than one type. Your bag is a mixture. Okay, so easy now. We know mixtures, so they combine, but the identities of each substance will be conserved. Okay, so the taste of cucumber will stay the taste of the cucumber. The taste of tomato will stay the same taste. So mixtures means when we mix or combine two or more substances together. Okay, and easy here. If you put, for example, sand with water, so sand will stay down and water will stay up. Okay, we know sand because it's denser than water. So we can see sand and we can see water. Okay, but now if you put, this is water, if you put sugar or salt, sugar or salt inside water, what will happen after mixing? Sugar and salt will be dissolved, disappeared in water. Why? So because sugar and salt are good salutes for water, but later you'll learn more about this. So we know sugar and salt disappear in water, so we can see only one component here, sugar and water, but we cannot see sugar, we can see only one component. Okay, so here they mixed completely. If they mixed completely, so we call this mixture, we call it what? Solution. So what is a solution? Is a mixture, is a mixture if the components mixed completely. So if they mixed completely, we call the mixture solution. So how we can compare between mixtures and solutions? One question, like physical change. I said to know this is physical change or not physical change, ask the question. Does the matter change? If it doesn't, so it's not, if it doesn't, so it's a physical change. If it does, it's not physical change. And here the same way, but not the same question. Ask yourself, can you see the components or you cannot see the components? If you can see the components, we call it mixture, like fruit salad. Okay, we can see the components. If you put oil and water, and we know oil will stay here, so we can see oil and we can see water, so this is what, this is mixture. But putting sugar in water or salt in water, if you put salt inside water, what will happen? Nothing, only one component, so we call it solution. Another example about solution, air is a solution. We cannot see nitrogen and hydrogen and oxygen, we cannot see, so they mixed completely, so we call it solution. Okay, but if you put sand plus iron, for example, iron nail, this is mixture or solution? Mixture, because we can see the sand and we can see the iron, we can see the iron. So again, we have mixtures and we have solution. So here they combined together, but we can see the components, we can see the components, and here we cannot see. The components. Example about mixtures, like salad, like sand plus water, like fruits, like water with soil, like sand with iron, and other examples. And solution, like what? Like juices, one component, milk, one component, like salt water, like sugar plus water, like air. So here, one question, if you can see the components, we call it mixture. If we cannot see the components, we call it solution. And we said before, solution is a mixture, but the mixing between the components is completely. If they evenly completed or mixed completely 100%, you can see only one component. So here we call this mixture solution. Okay? Now, we said before, oil plus water is what? Mixture or solution? Is a mixture. Why? Because we can see the components. Oil will not mix with water. This is water and oil will be here on the surface because its density less than the density of water. So we use oil. Oil hates water and water hates oil. And later you'll call any substance that loves water, we call it hydrophilic. And any substance that loves oil, we call it hydrophobic. So we can divide substances into two types, hydrophilic and hydrophobic, or loves water and loves oil. If the substance loves water, it hates oil, so they are enemies, like enemies. But we use water to clean oil, like in your kitchen, washing plates or your clothes. Sometimes will be you'll drop dots of oil here, or imagine this is a plate in your kitchen. After eating, you have to wash these plates. Okay, now how to clean oil by using water? We know we add one extra substance, detergents, like soap. Okay, we use detergents or soap or Tide to clean. Tide, this is the name of a cleaner or detergents or soap. Okay, what is the job of soap or detergent or Tide? Listen now. We said water and oil are enemies. They hate each other, so they will not combine. What will happen? Soap or detergent or Tide will come where? Here. And this includes two sides like this. The first side or the first part of detergent loves water, and the second one loves oil. Okay, so what will happen? This side will catch water and this side will catch oil. So what will happen? This oil will be removed by bubbles, so bubbles or Tide bubbles. So oil will be separated or removed from this plate or your cloth. Okay, so till now you have to know what is a mixture. Is a combination between two or more substances. Okay, and mixtures keep identities of these components. Okay, if the mixing is completely between the components, we call this mixture solution. Now, how to separate mixtures and solutions? How to separate mixtures and solutions? To separate the components of mixtures and solutions, it depends on the component. For example, if you have iron plus sand, iron is mixed with sand. To remove iron from sand, we use what? I have to know some physical properties about these things, and we know iron can be attracted to what? To magnets. So by using magnets, we can separate the mixture of iron and sand. So the best way to separate this mixture by using magnets. Okay, so this is the first one. The second one, if you have sand with water, and if you have salt with water. If we have sand with water, this mixture easy. We have papers in laboratories. This paper we call it what? Filter, and we use this word filter. So I'll put here, for example, measuring cup, and here in the top I'll put this paper. Then I'll drop the mixture here. What will happen? Water will go down and sand will stay up. So this process we call it filtration. So this what? Filtration. So filtration means to separate the solution. Okay, if you have solution, if you have mixture, you have to use filtration. But with solutions like salt and water, by using this paper, it will not benefit. Because what? Because salt is dissolved inside water. Okay, to separate salt from water here by boiling, or we call it evaporation. Boiling or evaporation. So to separate the components of mixtures and solutions, if you have iron and sand, so if you have metal with non-metal, you can use magnets to separate metals. Okay, if you have sand and water, means if you have a mixture that includes liquid and solid, you can use filtration. Okay, so filtration is used to separate the components of mixtures that they include liquids and solids. Okay, if you have mixture with solid and liquid, you can use filtration. Now with solutions, boiling or evaporation. Okay, evaporation or boiling we call it, to separate the components. Salt will stay and water will be evaporated. Okay, so you have to know the way of, or how to separate the components of mixtures and solutions. And these only examples: metals, a mixture of metal and non-metal, magnets; a mixture of water and of liquid and solid, filtration. Okay, solution, boiling. With solution we use boiling to separate the components. Okay, so I hope all of them are clear. Have a nice day, stay safe, and see you next video inshallah.